Welcome to Module-Oriented Approach Test Automation Framework webinar. The key innovation of module-oriented approach are as follow. Standard creation of test cases. Minimize software programming. Maximize reusability. Reduce time to develop. Simplify the maintenance and share your ideas efficiently. Test Tree Studio is combined of four main engines: Test Tree Manager, Test Tree Creator, Test Tree Runner, and Test Tree Presenter. In this slide, you can see the top-level configuration of Test Tree Studio and the standard interfaces where the software communicates with test stations and unit under test. In this slide, you can see the cloud-based architecture of Test Tree Studio and the way the four main engines communicate through an SQL server. Here is a snapshot of module-based ATE versus traditional method, which is script-based ATE. The followings are the main advantage of module-based architecture versus traditional method, which is script-based. In this slide, you can see the module-based test automation design engines along with all the appropriate modules to create your test cases. In here, you can see how easy it is to create your pre-functional and functional tests for two different types of product, product A and product B. Test Tree Studio is combined of three main sections: standard modules, advanced modules, and embedded modules. In this demo, we are showing a test instrument control using Test Tree Studio and how you can automate all the test sequence. The following main three steps would allow the user to create a fully automated test case using Test Tree Creator, Runner, and Presenter. Let's start our demo. Using Test Tree Creator, we are going to create a test case to calibrate test equipments. As part of network devices, select optical component PCB and add the process flow diagram which has been created previously by selecting and adding. Select the calibration process and download the test sequence files which has been created before. As you can see, a series of test cases are ready to be performed as part of the test sequence. Device I/O validation using send and read module. At this stage, we are going to run all the test cases that we have created previously using Test Tree Creator. All the test cases are ready to be run. Simply click the Run button and the tool will perform one by one all the test cases that we have previously created. Once all the test cases have been passed, the green dots indicates that the test has been successfully performed. We can create a test case using send and read module by simply drag and dropping it into the test sequence. The next level would be to give a module ID to the test case, and in the command properties window, fill out all the information. In this case, we are going to use a TCP/IP protocol to send and read the information from the module. Once this step is done, in the communication window, we can apply the selection and try command with default parser setting. Once this step is done, press the import button and provide a minimum and a maximum parameter for your test. Using external script module, drag and drop the script and execution model into your test case. Provide a module ID and a spec ID, and import an external command line into the tool. In this case, we are importing the PAT04 use attenuator read OSA. Using the same communication interface, import, apply, and try it. As you can see in the communication output window, the test is performing and the result is going to be shown in the middle window. Green means the test is successful. Save and move on to the next level. Test case creation using data module. Drag and drop the data module into your test case. In the command property windows, fill out the necessary information and using the same TCP/IP, send the data. We can see in the communication window the data which has been selected. Press import and then launch to bring us to another window. Select the information by using the separator and extract the string. We can simply create a row and column of the information, select the functional type, provide the spec ID, and the tool will create a column of the data we have created. click the button Save, and then Apply, and try it. The result of the test is successful as indicated with the green dot. Save and move to the next level. Validate variable object through equation module. Drag and drop the equation module into your test case. Provide a module ID and spec ID, and provide an expression that you want to execute. Select the type and the function and press Done. At this stage, the result can be selected with a minimum and a maximum result that you are targeting. Once this is done, click on the Apply and save the result. Test automation deployment using Test Tree Runner. In the runner, click the Open button to bring the unit information window. Scan the UUT and press OK. Once this is done, the test case will appear on the right side of the window. Select the calibration process and click Run to execute the test case. Several questions will be asked to the operator, and the operator has to validate these questions one by answering yes or no. Once all the questions have been answered, the calibration process will start. As you can see, the calibration process is doing one by one all the test cases that we have previously created. Our test station is doing the calibration based on the information that we have provided to Test Tree Runner and all the test cases that we have created previously. This includes the graphics and the self-calibration of the test instrument. Once the test case is completed, the operator has to remove the fiber from the UUT and proceed to the next level. Our tool has indicated how easy it is to create your test calibration process without writing a single line of code. This will help you to simplify your test development, easy to maintain, and reduce your cost. We hope this demo helped you understand better the capabilities and the power of our tool.